In this lesson, we will evaluate combined functions at a given point. So in this example, we will evaluate f over g at x equals -5. So first, let's get where f over g of -5 is equal to. That is just equal to f at -5 divided by g at -5. So to evaluate this means you replace the x here by the number here. So in this case, by -5. So you have -5 quantity squared minus 18. So you refer to your f of x. And then you replace the x here by -5. For your denominator, it's g of -5. That means you replace the x here by -5. So you have square root of -5 plus 5. Now, when you simplify this, the numerator is 25 minus 18, but the denominator is 0. So whatever the result is for the numerator, it would not matter. You would just say this one does not exist because the denominator is 0. Next, let's consider the following example. Evaluate f over g at 2, given that f of x is equal to the square root of 2x plus 1, and g of x is equal to 1 over x minus 3. Note that f over g at 2 is equal to f at 2 over g of 2. Now we can simplify first f at 2. So that means you can look at f here and then evaluate at 2. So that means you replace x here by 2. So you have square root of 2 times 2 plus 1. And that would be equal to, this is 4 plus 1, that's 5. So that is equal to the square root of 5. Then also evaluate g of 2. G of 2 here is equal to 1 over, then you replace x here by 2. 2 minus 3, which is equal to 1 over 2 minus 3, which is -1. And 1 over -1 is -1. Now, going back to our problem, so since this is f of 2 and this is g of 2, we will go ahead and plug it in. So the numerator is square root of 5. The denominator is g of 2, which is -1. So this is equal to the negative square root of 5. For the next example, we are given here the graphs of f of x and g of x, and we want to use that to evaluate each of the expression here. So first, let's have f plus g of 4. We know that this is equal to f of 4 plus g of 4. So to evaluate this, let's go ahead and find the value of the function when x is equal to 4. So when x is equal to 4, you can draw a line and see where this one would intersect at your graph. Now at the red curve, that's the graph of g of x. This line intersects at this point, and that corresponds to 12. So that means your g of 4 is 12. Then your f at 4, this line also intersects at the line here, the blue curve. That's for your f of x. When x is equal to 4, the value here is -3. So that's -3. So -3 plus 12 is equal to 9. So f plus g of 4 is 9. Next, let's evaluate f times g at 0. Now f times g at 0 is equal to f at 0 times g at 0. So let's go look ahead and locate x equals 0. X equals 0 is this point here, and see where it would, so let's make a vertical line and see where it would intersect at your graph. So at the intersection at the red line, that's for your g of x. So g at 0 is equal to 4. And for the blue curve, that's your f at 0 is equal to 1. So this means f at 0 is 1. G at 0 is this point here, which is 4. So 1 times 4 is equal to 4. Next, let's evaluate g minus f at 1. This is equal to g at 1 minus f at 1. Now g at x equals 1, this point here. Okay, so let's make a line. So now that at this point, that is g at 1, and this is f at x equals 1. And then let's plug in values. So when x is equal to 1, g of 1 is equal to 6. Minus f at 1. When f is equal to 1, f at 1 is 0. It intersects the x-axis. So that is 0. So 6 minus 0 is 6. Now lastly, we have f over g at negative 2. This is equal to f at negative 2 divided by g at negative 2. So locate negative 2 on the graph. That is this point here. That's negative 2. And then just draw a line passing through negative 2 and see where it would intersect at your curve. Now here it intersects at this point on the red line, and on the blue line intersects at that point. So on the red, that is your g. So g at negative 2 is equal to 0. The y value is 0. Now f at negative 2 is equal to negative 1. Now if you have constant over 0, that means it is undefined. Or you say does not exist.